I had an interesting conversation with Flatzoid today on his Discord server. It all started with MC Scorpio81 posting a meme about a Selenelion eclipse, claiming that the shadow should not come over the moon from the top, or to put it in different terms, that the moon should not enter the Earth's shadow from the bottom. Ruhif responded with a link to his video, which is a good one, I recommend that you watch it. I'll put a link in the description. However, as you can see, that got only a clown emoji in response. I decided to continue the topic for a bit. I asked why would they expect the shadow to come from the bottom. MC Scorpio81 didn't answer, he was probably offline. Another user, Michael Khan, appeared and offered a few expletives and nothing of substance. The person who did try to start a normal discussion was Flatzoid. He said, it should come from the bottom because the story is the Earth is in the way. Now, I don't really get this logic, so I tried to offer a more detailed explanation. I agreed that the Earth is in the way, but that this doesn't rule out the shadow coming from the top. I won't read my message in its entirety. If you're interested, you can pause the video and take a moment to read what I wrote. As a side note, the messages I'll be showing from this point on are just some of the messages that were exchanged. It would be pointless to show all of them, and the ones I show should provide a complete enough picture of the conversation. So, a bit later, Flatzoid told me that I don't understand how shadows are cast and that the sun has already set. Now, this particular photo was taken before sunrise, which I pointed out in my next message. This, however, didn't convince Flatzoid, who brought into question whether this fact even matters. You could even say he seemed surprised that I thought it mattered. I confirmed that it mattered though, because it did. In fact, we shouldn't expect the shadow to be coming from the top during sunset. Then the shadow should be coming from the bottom indeed. I tried to outline the reasons. Unfortunately, I must not have been clear enough, because Flatzoid requested a drawing. Well then, I attempted to make one. This is actually quite close to what Ruhif showed in his video, only he did that with just one observer and I added a second one. We have observer 1 that watches the eclipse during sunset and moonrise, and observer 2 who watches it during sunrise and moonset. And as we can see, only observer 2 will see the shadow coming from the top. Observer 1, being rotated 180 degrees relative to observer 2, sees it the opposite way. This didn't convince Flatzoid either. He decided that my picture proves that I cannot think in 3D. I expressed my disagreement, pointing out that in my opinion it was Flatzoid who had trouble with 3D in this case. I also mentioned that if I could use Blender, I'd simply model this situation in 3D. Flatzoid seemed to like this idea. Cool, slight problem. My skills with Blender are next to non-existent. However, I did launch Blender and through some trial and error I managed to put together a model which I'm going to show you now. Here you can see the Earth and the Moon being lit by the sun that is placed along the x-axis, which is somewhere there. And so the light falls on the objects from that direction. So Earth is being lit from the direction of the positive x-axis, this is this red line. And I can show you that the moon is lit this way as well. As you can see, it's also lit from this side, only this part is already in Earth's shadow. And we can actually see this here, but I will talk about that a bit later. So let's go back to Earth for a moment. Oh, maybe before we do that, let me just point out that as you can see, the moon is slightly off the x-axis right now. That's because when I run the animation, basically I set it up so that the moon will move into the shadow. And this is all actually to scale, so the moon will go into the shadow with the speed that is actually scaled proportionally to the speed that the actual moon goes into the shadow during an eclipse. And the Earth will also rotate by an angle that is scaled proportionally to the time. So let's go back to the Earth. And let's look here as well. So I set up two observers on the Earth. One is here. And we can see what this observer sees here in this window. So we can see that this observer currently sees the moon, which is partially eclipsed. And the second observer is here. And what this observer sees, we can see here in this window. and we can see that this observer doesn't see the moon yet. But when the Earth rotates, actually this observer will see the moon setting because the Earth will rotate this way. So this corresponds to an observer on the equator looking west, and this one corresponds to the observer on the equator looking east, and this one will see the moon rise because it will basically rotate into view. And while the Earth rotates, the moon will move deeper into the shadow, so that's what we will see. So let me now run the animation, and we can see that the moon sets here, rises here, and we can see that for the observer that sees the moon setting, the shadow comes from the top, so basically the moon is getting eclipsed more and more, but it is being, let's say, eaten from the top. And this observer also sees the moon being eclipsed more and more, which is to be expected because they are looking at the same exact moon. Only this observer, because it's oriented differently, they see the moon being eclipsed from the bottom. And as the time passes, the moon rises more and more for this observer and sets for this observer. So let's run this, and the moon set here and rises here. And we can see this from the start again. So if we look closely here, we can see the Earth actually rotating this way slightly. It's just by a few degrees. The runtime of this animation is something like 40 minutes in real time. So it's just like 10 degrees rotation. And the moon, let me actually go to the moon here so that you can see that it moves slightly here. And during 40 minutes it moves by about 2,400 kilometers, so that's how this is scaled. And we can see that it moves deeper and deeper into the shadow. But yeah, what's important here is what the observers see, and as we can see, it's basically what I told Flatzoid they would see. So one of them sees the moon being eclipsed from the top, the one that sees the moon setting, and the one that sees the moon rising sees it being eclipsed from the bottom. And one more thing which I noticed is confusing sometimes. Since the moon's orbit isn't exactly in the equatorial plane of Earth, it means that sometimes during an eclipse, the moon doesn't pass directly through the center of the shadow. So for example, here I lifted the moon somewhat from the equatorial plane of the Earth, and I will make it pass through the shadow, through the top of the shadow. Which means the shadow will seem to come over the moon from a bit of a weird direction, as we will see here in these animations. So let me just play the animation. And as we can see, the moon enters like at the top, and here we can see that the shadow comes somewhat from the side, like from the bottom right, and here from the top left. So that's why sometimes it isn't that intuitive. So I think that's it for this video. If you have some suggestions, please let me know, although I can't promise that I will actually implement them because, as I've said, my skills in Blender are really bad, and I really struggled to prepare even this simple animation. So yeah, don't count on me if you have some good ideas, but if they are really good, I mean, I can try. But as I said, I can't promise anything. Anyway, thanks for watching and see you in the next one.